7.1, all kinds of energy, from page 130 to 133. How are all of these things in these pictures related? So we have a bungee jumper, battery, somebody warming at a fire, a roller coaster, electricity, light, sound, and a nuclear power plant. Think about this for just a second here. All of these are different types of energy. So we have potential energy when we have height because of gravity. We have chemical energy stored in a battery. We have thermal or heat energy from a source of fire or warmth. Kinetic energy when we have motion on our roller coaster. We have electrical energy charging the battery within our phone. So these may be a little linked. We have light energy, the energy that light emits itself. We have sound energy from the sound waves. And we have nuclear energy from the Springfield nuclear power plant, of course. So they're all sources of energy, and the definition of energy is the ability to do work or to make things move. Now, it might seem counterintuitive because in electrical energy, our phone wasn't moving. We're not seeing anything move, but we know that electricity is actually electrons. Electrons are moving in our electrical energy. In sound energy, we don't see anything. We can feel it at a concert, though, if you're standing really close to a speaker. We can feel the waves of sound pulsing. So sound is still a transfer of energy. It's just something we can't see. It is a sound wave. Same with light. It is a light wave. So what is work? We've used it to define energy, which is the ability to do work. So what is work? Well, a few little definitions here first. A force is a push or a pull. So you're applying a force when you push on something or pull on something. Force has units of newtons. Work is done when a force moves an object. So it actually has to cover some sort of distance. Work is given units of Newton meters or a joule. So these two units are said to be equivalent. Work can be calculated using this formula, that work is equal to the force times the distance that force is applied over, aka the distance that our object moves. So how much work is done when a force of 18 newtons is applied to lift a stack of books 0.7 meters? Well, we have a force of 18 newtons, and we are applying that force over a distance of 0.75 meters. Work is equal to force times distance. So we get 18 newtons times 0.75 meters. I calculate an answer of 13.5. Now this here needs units. Remember, we can write units of Newton meters. Now this little dot just means that these are two separate units multiplied together, okay? Just to try and keep it separate, or you can tell what units are there. But I can also say that this is 13.5 joules. Remember, a joule is the exact same thing as a Newton meter. So, multiplying our force by our distance, we get our work applied. Simple machines have one movement, like an inclined plane, aka a ramp. It's a simple machine because its one movement is a slide, whether we are sliding something up or sliding something down our ramp. So of course we know some examples: ramps to enter buildings, like a gradual wading pool or the wave pools. Threads of a screw cap are a form of a ramp. So in our screw cap, my beautiful drawings here, we have this thread working its way up the cap. If we were to unwind that, we would see that it gradually works its way up the cap. Now, obviously, this is a terrible drawing. But if we were to unwind the cap, we would see this thread working its way up as a ramp. Okay, so any threaded object is actually an incline. It just is wrapped around, circular, overlapped on top of itself. It's really tricky to imagine that, I can understand. So when are you doing work? When a force is applied to an object and that object moves in the direction of the force. So which of the following scenarios is an example of work? A cyclist is coasting down the hill. If you're coasting down a hill, you're traveling a distance, but you're not applying a force. You are not pedaling. So this is not an example of work because there is no force applied. If you lift your backpack, let's say from the ground to put on your shoulder, you have applied a force, you have pulled your backpack from the ground, and you have covered a distance. So this is an example of work because it meets both the conditions of a force applied over a distance. Someone pushing on a piano that doesn't move. They are applying a force, they are pushing, but the piano did not move. So because no distance covered. 0 distance covered. If you are doing a pull-up, if you are pulling yourself up like a chin-up, if you will, you are applying a force, holding your body and moving your body weight up over a distance. So this is considered work. Some practice on page 133. There's number 1, 2, and 3 for you to take a look at.